going to make half an announcement. That is, I don't have all the information I need to give you, but in a few days there's going to be online an opportunity for you to provide feedback anonymously about this class. I imagine it's for all of your classes. The only information I have now, I think, I've heard it's through Canvas. And if anybody else knows any more about how you get to this opportunity, let me know. Otherwise, I will try and find out exactly what the process is. You can have it until December 12th. And the only thing I get to see right now is how many people have done it. So I'll probably be bugging people from, I think it's the 22nd it starts. So from then on, I'll be bugging people to fill these out. It's useful for the school, it's useful for me, and I hope you'll all participate. Okay. I want to kind of summarize where we are here. We've been working on solving triangles, that is, being able to find the parts of it, some of the parts of a triangle given at least 3 components. We have a whole bunch of tools now. We have the trig functions, sine, cosine, tangent. We have the Pythagorean theorem. And on Monday, we looked at something called the law of sines. Just to review that, if you have some triangle with angles A, B, and C, and sides opposite A, B, and C, that we know that the sine of angle A over A is equal to the sine of angle B over B, and of course, sine of angle C over C. Well, I've been trying to, expose the use of these things through the idea that there's a connection between triangle congruences and the triangles that are solvable. So let's put those up on the board again. There's SSS, side to side, side, angle, side, angle, which is pretty much the same as angle, side, and hypotenuse leg. Hypotenuse leg pretty much taken care of with our trig functions and the Pythagorean theorem that refers to a right triangle. So we're kind of done with this. Angle side angle was a bit of a problem until we had the law of sines to help us out. You have some triangle and you know an angle and the you have 2 angles, and you know the included side. Well, then you have the 3rd angle because you know sum of the angles in a triangle is 180. And then you have this ratio sine of angle C over C. And then you have these other two equivalent, equal ratios that you find being A and B. So we've taken care of almost everything, except now we have SSS and SAS to look at. Let's take a look at what that means. So SSS would mean I have a triangle where I know A, B, and C, the sides, and I want to know the angles. And were this a right triangle, it would be okay, because I could use my inverse trig functions. But we don't know how to do that yet. We're going to learn today how to deal with that. The other kind of problem we might run into would be, we know two of the sides, and we know the angle between them. The law of sines doesn't do us any good here because we can't complete any of these ratios. So we're kind of stuck. So we need something new. We need a new tool. And this is kind of the last tool. And this tool is called the law of cosines. All right. Well, we need to know what the law of cosines is. So, let's see. Anything else to get out? All right. So we start with a triangle. Some general triangle. Is angles or vertices we're going to label A, B, and C. And we label the sides small a, small b, and small c. And as we've done a number of times before, we're going to drop perpendicular, turn this triangle into two right triangles. We're going to label one of the segments that this altitude breaks side C into x. That's just the length x. And so the other segment is going to be C minus x. So let's just leave those here for now. All right, I want to make a real minor observation here. Since this is a right triangle, x is the leg and b is the hypotenuse, I know that x over b is going to be cosine of A. Or solving for x is b times the cosine of angle A. Okay, we're going to use this later, but we wanted to hold on to it. Okay. The next thing I'm going to observe is that, let's label the altitude h for height. The next thing to observe is I can apply the Pythagorean theorem to both of these triangles. So I want to do that. So that's going to tell me that b squared is going to equal x squared plus h squared. And similarly, I'm going to have a squared equal to what? C minus x squared plus h squared. Well, that's a lot of letters, so it probably would be good if I could get rid of some of them. So the obvious thing to do is to solve for h squared on one of these and substitute. So if I say h squared equals d squared minus x squared over here, I can then plug that in over here. A squared equals c minus x squared plus b squared minus x squared. Okay? I'd like to get rid of x too, because that really doesn't have anything to do with, my original triangle, other than just happens to be a feature. So how would I do that? Well, let's multiply the c minus x squared out. B squared equals c squared minus 2cx plus x squared plus b squared minus x squared. I didn't do that too fast. This is just this piece here, c minus x. Well, that's great, because now I can get rid of my x squared. So I have a squared equals c squared minus 2cx plus b squared. And I'm almost done. I just have this x here to deal with. Oh, but I have kind of a definition of x here without anything I prefer not to use. So let's try that. A squared equals c squared minus 2c times b cosine angle A plus b squared. And I'm just going to rearrange that a little bit to my liking. I'm going to say a squared equals b squared plus c squared minus 2bc cosine angle A. And that's my law of sines, law of cosines. There's a few things to observe about this. The labeling A, B, and C is arbitrary, so you're more likely to see this written this way. Let me write this over here so everybody can see it. C squared equals a squared plus b squared minus 2ab cosine angle C. Okay, basically I just rearranged the A, B's, and C's. The reason we usually see it in this form is that this reminds us a little bit of another theorem that we're used to, the Pythagorean theorem. It has this little extra here. This theorem is not limited to any kind of triangle, the way a right triangle is, but if we had a right triangle, and my right angle here was C, so this would be the hypotenuse, and A and B would be the legs. Well, what's the cosine of 90 degrees? 0. Yeah. So this, in a right triangle, this just becomes the Pythagorean theorem. Another way to look at this is if I rearrange this as c squared equals a squared minus 2ab cosine angle c plus b squared. This sort of looks like a pattern we're used to. It just has this annoying cosine angle c here. If we think for a minute, where is angle cosine c equal to just plain 1? Where's the cosine 1? Anyone? Yes?
180, maybe?
I think it would be minus 1 and 180. I'm going to use that in a minute. Henrietta, did you have a different?
At 0 and 360 degrees? At 0 and 360?
360, yeah. But also 0, right? Okay, let's forget for a second what would that mean. But if cosine of c were 1, this would be a squared minus 2ab plus b squared. That would be just a minus b squared. So let me see if I can draw that. So that says the angle between A, there's my A, and B, all right, these have a 0 angle. That's really pushing my luck here. There's my A, there's my B, but then this would be C, right? Well, I guess I have it backwards. I guess this should be B. This should be B, and this should be A. Oh, well, that kind of makes sense. A minus B is C, so A minus B squared is C squared. If instead of plugging in 0 here, I plug in 180 degrees, that would be -1, so this would become positive, and we have c squared equals a plus b squared, which would just be the same kind of thing, except now we would have a here and b here, and then this would be c. So of course, then we just have our pattern for the sum of a square of the sum. In other words, these just two represent a triangle where we've just collapsed it all the way down. And the formula still works, even though it's no longer really a triangle. Okay, any questions about this? This is like the law of sine. This is a formula definitely worth memorizing, although I would suggest you take advantage of the fact that it looks a lot like the Pythagorean theorem. Then you just have to remember what the extra is, right? It's going to be minus 2 times 1 in each of these, AB, times the cosine of this angle. All right, this is going to be really useful. let's take a look at a problem or two. Okay, let's start with an SSS problem. That is, I have a triangle. It has sides 5, 6, and 7. And to solve this, I need to know what the 3 missing angles are. I have some choice here. I can, yes, let me write up here. I can choose, either side is A, B, or C. So, why don't we be a little traditional? Let's call 5A, 6B, 7C, and we plug in our values. So we have 7 squared equals 6 squared plus 5 squared, minus 2 times 6 times 5 cosine angle C, or solving for cosine of angle C, we get what? 7 squared minus 6 squared minus 5 squared all over 2 times 6 times 5. So, what is that? 7 squared, I'm being lazy here. That's 7 squared, oops. 7 squared minus 6 squared minus 5 squared is quit. See, I should have done that. 49 minus 36 minus 25 is minus 12 over 60. Or minus 2/10 minus 1/5, I guess. Okay, well that's interesting. It's minus, right? My cosine is minus. What does that mean? I mean, between 0 and 90 degrees, my cosine is positive, right? It goes from 1 up to 0. What happens if it's negative? Except we can't do that with a triangle, can we? We don't really have negative. It would be negative in the no, it would be negative in the 3rd quadrant. But it's also negative in the 2nd quadrant. That tells me my angle here is going to be, what? It's going to be obtuse. It's going to be greater than 90 degrees. Okay, so what's the, check my mode, of course. What's the inverse cosine of minus 1/5? 101 degrees. Okay, 101.5 degrees. All right, that's the big breakthrough. All right, now there's a few different ways to complete this, right? Because now I have got side angle side. I take it back. Maybe I think I still need to use the law of cosines here. The last angle I'll just get because they sum up to 180. All right, let's do it again. is, we call this angle C, right? So let's go for angle B, right? So B squared, use lowercase here, B squared equals A squared plus C squared minus 2, what? There's a simple pattern here you should be thinking about. AC, and then what? Cosine of angle D, all right. Okay, so 36 equals 25 plus 49 minus 2 times 35. Cosine angle B, or cosine angle B equals 36 minus 25 minus 49, or minus 2 times 35, that's minus 70. I mean, we could just, you know, go right to a formula for the angle if we wanted. Here we could say angle C is what? C squared minus A squared minus B squared over minus 2AB cosine inverse, right? We could do that. First cosine 36 minus 25 minus, I forgot I needed an extra parentheses. Minus 25 minus 49 divided by minus 70. We get 57.1. 57.1. Okay, which that was over here, 57.1. So now I can just add these two together and subtract from 180. 1 point, approximately 57.1 subtracted from 180, I get 21.4 degrees. So I can solve an SSS problem now, right? And here I have the law of cosines. Here I have the law of sines. Questions about this? This is real basic stuff, but you can expect in the near future problems where I give you a triangle and I say, here's two sides or two angles and a side, any three components, and you should be able to find all the missing parts. But we're not quite finished. We still have one more case to deal with. That's the side angle side. So let's take a look at an example. Here I have a triangle with a known angle and two known sides. So let me call this angle C here. This is side C. And again, it doesn't really matter which of these is A and B. So again, the law of sines doesn't help me here because I don't have a complete ratio that I can use. But I can apply the law of cosines. Right? I have A, B, and C. I ought to be able to find the third side. So let's see how that would work. I would say C squared equals A squared, which would be 6 squared plus 10 squared minus 2 times 6 times 10 times the cosine of 38 degrees. Or c equals square root of 36 plus 100 minus 120 times the cosine of 38 degrees. We know this is going to be positive because we don't have triangles with negative sides. All right, again, this is kind of a calculator problem. So 136 minus 120 cosine 38, and I get 6.44. All right, well, now where am I? What am I going to do to find these two angles? Anyone have any ideas on how to find those two angles? I think I've done all I can with the, that's not true. I mean, I have 3 sides, so I could go back and use the law of cosine again. But I also have a ratio here, c and the sine of 38. So I could use the law of sines to complete this. I guess we should try one of those. So we know that the sine of 38 degrees over 6.44 will equal, I guess this is now angle C, sine of angle C over 10. So we can just solve this for sine of angle C is 10 over 6.44 times the sine of 38 degrees. Just a general comment, at some point you'll be, yeah, go ahead. Say again? This sine of angle C over 10, sine of, oh, thank you. Angle B, thank you. Does that look right now? Thank you. Appreciate that. At some point, you know, you'll be doing an exam, and maybe you'll have a calculator and maybe you won't. This would be a perfectly fine answer. Or, well, I would do a little something with this. I'd add 36 and 100, but that would be a perfectly good answer for what is C. Anything else we do is probably going to be an approximation. And while I think you need to know how to use your calculator, that's not a particular skill we're going to test for here. Okay, so now we know that SAS is also, you can defeat it with the law of cosines. Just so we're really complete here, it's not, again, it's not a triangle congruence theorem, but side-side angle. Right? Recall that there are three possibilities with side-side angle. You know, why did I thought of this? Because there's actually something I missed on Monday. One possibility is you have a side and an angle, right? And another side, but you actually you can get two different triangles. That's one possibility. Another possibility is you have a side which just happens to be the hypotenuse of a right triangle, in which case you get one solution. And you could have kind of a non-solution, where the second side isn't long enough to reach down, you get zero solutions. There's one more situation I hadn't really thought of. What if you have some angle and the second side is longer than the first side? Well, then you just get one solution also. You can't do this trick where the side could go either way, and this angle could either be some value or a supplement. So that's something to keep in mind. If in this case, if side A is less than side B, then you're only going to get one solution. That's it. That's how to solve triangles. That's pretty much all there is. You don't necessarily have to know this chart, but you do know how to deal with all these possible situations, including now we have 4 categories under SSA. Any questions on this? This is really we're going to move on and do some other things with trigonometry, but this is one of the most basic parts you need to know. All right, why don't we look at a couple more problems, just so we're on track. Okay, so say I have a triangle and I know that the angles are 25 and 32 degrees, and I know that this side here is 10. So this is angle side angle. So how am I gonna go after this? Finding the other 3 missing parts. How would I do that? If you're pretty sure on how to do this, you should kind of think about being brave and raising your hand. And if you're not sure, you want to really pay close attention. Alex, what would you do first?
I would label outside as like A, B, and C, and use the law of sides.
A, B, and C. Okay.
And do,
Wait a minute. Okay. Wait a minute. I think you're on the right track. there's a step.
Yeah, I use a lot of those answers. Yeah, it's like,
Give a second to, Alex, no, you know, it's okay to drown a little, right? It's okay, that's how we learn. So we're gonna use the law of cosines, wanna try that? I'll write them up on the board too here. Sine of angle A over A equals sine of angle B over B, sine of angle C over C, and C squared equals C squared plus B squared minus AB cosine angle C. Yes. I think you can apply the law of cosines here.
No, because I didn't see that second angle there. The angle for A is 123.
The angle, oh, wait. Okay, so the first step is, angle side angle is to find the
There's that
third angle. Third angle. You were going to say that? Okay. All right, so 180 minus 25 minus 32, what do I get? 57, so 123. Is that what you said?
Yeah, 123.
Okay. All right, very good. That's the first step. What do I do now? What can I do now?
Use the law of sine.
Well, it's sines. Okay, do you want to give me some detail?
Sine 123
Okay, over
over 10.
equals. You have a choice, right?
Sine.
We call this B, this is C, that's A, right? Sine of over B. Okay, very good, thank you. Does everyone see that? Right? Angle side angle, we find the third angle because we're going to need it. The sine of that over its opposite side, that's our ratio here we can use. And now, now we have an equation in one variable b, we can solve for b. B in this case 10 sine of 25 degrees over sine of 123 degrees. And you can do the same thing here with side C, and angle C. Okay, that's angle side angle, that worked. Right? So what if I had a triangle where, say this is 60 degrees, and this side is, say, 10, and this side is, let's say, 6. Okay, how would we go about dealing with that? And again, just A, B, and C, and then this is my little b, my little a, and my little c. What am I going to do with that? Okay, we could try the law of cosines. I guess we would want, since I'm saying a here, we would want a squared equals b squared plus c squared minus 2bc cosine angle A. Is that what you had in mind? Okay, so little a is 36 equals 100 plus c squared minus 2 times 10 cosine of angle A. This again should just about be on the tip of your tongue. 60 degrees. Yes? 1/2. So this is 1/2. So, okay. So 36 minus 100 equals c squared, 2 times 10 times 1/2, minus 10c. Let's put everything on one side here. So this is going to be c squared minus 10c plus 64 equals 0. Interesting, we've got a quadratic. Maybe we'll get 2 solutions. All right, so quadratic formula, 10 plus or minus the square root of 100 minus 4ac, 24, 256 all over 2. So 10 plus or minus, that's square root of minus 156. Well, that's interesting. We got an imaginary solution. They're both imaginary. What went wrong here? Why are we not getting a real solution here? This is probably this shouldn't be hard, but it'd probably be the hardest thing we're going to do. Run into a little roadblock here. What went wrong? Anyone see?
Like with what we use or just what we
Well, we're not getting any solution here, right? I mean, we don't have triangles with complex sides, right? So basically, there's no solution. But I'm asking why? Why is there no solution? Take you up on your interesting idea. Let's use the law of sines, right? So what are we going to have? We're going to have sine of 60 degrees over 6 is going to equal to which one? I guess B, right? Sine of angle B over 10. So we have sine of angle B equals 10 sine of 60 degrees over 6, or B equals the inverse sine of 10 sine of 60 degrees over 6. I see people with calculators. Well, give that a try. What happens?
Here. Here.
Error. Okay. Anyone have any more information on what kind of error we have here? Domain error. Oh, boy. Hold on. This is 10 times sine of 60. That's about square root of 3 over 2 over 6. So that's 5 times the square root of 3 over 6. Square root of 3 is about 1.7. 1.7 times 5 is 8.5 over 6. What happens when I try and find the inverse sine of 8.5 over 6? That's greater than 1. It's not in the domain. So we run into another brick wall, right? It was a good idea. Try something different. So now we have to go back and think, what's wrong with this?
Is it because we can split the triangle in half?
Well, here's a good question. What is the height of this hypotenuse? This is a 30, 60, 90 triangle. I know this is a half root of 10, so that's 5. 5 square root of 3, what's 5 square root of 3? Oh, it's about 8.5. So how can this side be 6? You can't really, it's just dangling down here. Okay? So if I give you a side angle problem, be skeptical. Is it really a triangle? I mean, it might be a triangle. It might have two triangles, but in this case it might be no triangles. All right, let's do you have time for one more? Yeah, let's do one more. Now, we're going to do two more. The first one you're going to look at and you're going to tell me real quickly what's wrong with it. So this is 2, this is 3, this is 8. Okay, what's wrong with that? I mean, I drew it, but yeah.
It's always it's not a triangle.
Yeah, it's not a triangle. Like, this is 2, this is 3, 8 would be over here, right? This is only 5, right? So that's kind of a non-problem. So let's make it reasonable. How about 4, right? So how would I go about finding the angles for this? What would I use? What would I use if I have 3 sides of the triangle? Anyone agree with that? Law of cosines. Okay, thank you. Law of cosines. SSS. Okay, someone in the 3rd row, tell me how I would apply the law of cosines. Please. Anybody? All right, I guess I'm going to give up. You will get a chance to do an SSS in the homework. I guess that's it for today. Thank you.